I am going to explain our circuit schematics and why it is designed this way. The main components of our circuit are the logic gates, a battery pack which acts as a power source, light bulbs to indicate sum and carry out, a switch to control A, B and C inputs, and resistors. The logic gates that we used are one XOR gate, one AND gate, and one OR gate. On the switch, the line that is coming out of 1 represents input A, 2 input B, and 3 input carry in. The red light bulb represents sum, while the green light bulb represents the carry out. The red wires on the right side of the gate and the ones near the switch are used to connect the gates and the switch to VDD respectively, while the red wires on the left side of the gate are to connect the output of the gates to the light bulbs. The black wires are then used to ground the components. Finally, the different colored wires are used to connect the inputs near the switch to the gates, as well as the connections in between the gates. Orange is for A, green is for B, yellow is for C in, and blue is for the connections in between the gates. Finally, the resistors at the switch are used to ensure that the inputs are low when the switch is open. Meanwhile, the resistors at the bulb is to prevent the bulb from having too much current and preventing it from being blown. This circuit is highly compact and minimal space on the PCB is used. It is also color coded so that the wires can be easily identified and it's obvious what they connect to and the role they serve. When inputs A, B, and C in are all 0, the subsequent output, sum, and carry out are both 0. So here's our demonstration for our full bit adder. As seen from the truth table, when there is a single input 1 from the inputs A, B, or C in, the value of the sum will be 1, and subsequently the red light bulb which represents the sum will be lit up. Now, when there are two inputs of 1 from A, B, or C in, the value of the sum is 0 while the carryout is 1. Thus, we will see that the green light, which represents the carryout, will now be lit up. Finally, when all the inputs are 1, the value of both the sum and the carryout will be 1. Thus, you will see both the green and red lights lit up. So here is our FPGA setup. The first mode is our auto mode. The center button is used to initialize the auto mode. The group of LED lights indicate A, B, and C in from right to left. The 7-segment displays show the input of the module, with the left digit being the sum and the right digit being the carry out. What this does is it cycles through all possible output combinations, which will lead to the corresponding input from the full bit adder. Next, we have our manual mode. The left and right buttons are used to cycle through the different states. The left button will bring you back a state, while the right button brings you to the next state. As you can see, depending on the state of the module, the outputs will differ and the inputs will correspond to the given outputs, as would a full adder.